Okay, so I will just present briefly the University of Geneva, the physics department, briefly our studies, all the study we provide here from the bachelor to the PhD, and then I will move a little bit about on the physics section itself, our specialties, and then on the master and all the orientations we have for the master. So the section of physics at University of Geneva is really a lively place because it's a pretty small one. I mean, it's a human-sized one. So it's very a lively place where students, teachers, and everybody is working quite closely together. Since we all of us, we know each other. That's really like a familiar section. Of course, I suppose all universities say the same, but we have an ambition for excellence, and this is kind of obvious. Of course, we want to be really competitive in Switzerland, in Europe, and also all around the world. Thanks to Geneva, also geography, Geneva is a diplomatic capital of Switzerland, so it's really an international atmosphere, an international place. We have a really good exchange with all the international organization in Geneva. In physics, the most known one, the most famous one is CERN. Of course, we are like 15 kilometers far from CERN. So it's really a place where exchange are really easy. With all the organization, the international organization. Also, we have a full range of specialization, so I will tell a bit more about that later. And we have quite also a strong focus on the application of fundamental physics. We have 4 departments, and a full one is totally dedicated to applied physics. So this is basically to give a context of the physics section in Geneva. So as you know, you are students in bachelor, you're finishing your bachelor, I guess. Studying physics is not that easy, but also but of course worth it. But what we try to do here in Geneva and what we are doing really to reach an excellence in education and research, so that you are in really a very cutting edge place where everything is up to date. Even if the building might look a bit old, what we're doing inside is quite modern and quite interesting. There is a very strong commitment of the faculty and the activities of the physics department, of course. We have a very open and active relationship between students and teacher. Maybe this is something we can discuss a bit more in detail later in the questions. But what I can say right now is we have something like 1 teacher for 8 students here, which means that we all know each other. And if a student has a question, it just has to knock at the door of the professor, and then he will take some time to explain whatever. And we are so at the state of the art of the teaching material. Of course, we are not teaching the same way now in 2021 that we did in 1950s. The physics section is also quite competitive on a European and on a worldwide scale. This year we reached the 18th position in the world in the Shanghai ranking for the physics itself, not science, not the global university, but physics itself. We came into the top 20, which is quite cool. Probably the Nobel Prize from Michel Mayor and Didier Queloz 2 years ago helped a little bit to go a bit higher in the ranking, but still it's a good place in the ranking. So we have the basic courses at the physics department. You know what a bachelor in physics is. So you know that you have done already quite a lot of math. We are providing all the basic courses in physics, electrodynamics, mechanics, thermodynamics. This is something I will not spend a lot of time about that here because you have finished your bachelor. We have introductory courses which orientate a little bit to the masters, like particle physics, nuclear physics, solid state physics, astrophysics, and also some optional course and labs. During the bachelor, the students spend something like 1 day per week in the labs. So after the bachelor, you reach the master, which is 2 years long, and this is why you are here right now. So the master in physics at the physics department, we have 5 orientations, which are related to the 4 departments. The first one is elementary particles and nuclear physics. The second one is quantum matter physics, theoretical physics, applied physics, and the last one is 2 years old because the nuclear physics department and theoretical physics, they opened a new master because astroparticle physics is increasing a lot in our department. And we figured out that it was necessary to have a master dedicated to this kind of research. So for all the master, there is specialized courses, of course, dedicated to the topic you choose. There are some optional courses, and you will see a bit later with the number of credits it gives, but the labs are very important. How is it organized? The first year is only courses and labs. So it's 60 credits. And you spend the whole year in lectures and exercise and lab. And the whole second year, the semester 3 and semester 4, is actually doing a master thesis project in one of the 5 specialization, and this gives 60 credits also. So it's really like 1 year of courses, 1 year of training period in the lab. Usually this training period leads to the PhD, which is 3 to 5 years here in Switzerland. Usually it's about it. I mean, most of the people are doing the PhD within 4 years. 3 is a bit short, 5 is a bit long, but still. And also after the master, you can do a Master of Advanced Studies, which is more professional training. Actually, I think we don't have any student in the Master of Advanced Studies for 2 years now. It's something which is more like engineering school than really research and PhD. So most of our students are doing a PhD. So this is the organization of the studies here. Actually, we signed the Bologna Agreement, so it's the same all around Europe. So the numbers, just to give you a hint. At the physics department, we have 350 staff members, about 40 professors, 13 advanced researchers, 31 scientific staff, and quite also some administrative people and technical staff. And we have a lot of students within those 350 staff members, like 105 PhD students, which is quite a big amount. The first year in the bachelor, we have 70 students, less than 70 students. And during the PhD, we have more than 100. So quite a lot of PhD students are coming from abroad. Sometimes they come during the master or for the masters, and a lot of them are coming for the PhD itself. And we have more than 60 postdocs also, and about 15 lecturers. So this is the team, which is quite big. That's why I said there is like a professor for one professor for eight students. In the section also, we have a lot of collaboration in which you can work. We have, of course, collaboration with all the European organizations like CERN, ESA, NASA, ESO. We sent quite some satellites in the previous years. There are some experiments on the International Space Station. We have satellites that are just working by themselves in orbit. We have collaboration with the observatory in Geneva. On the right side, you see Phasis and ID Quantic, which are 2 startups which came from the applied physics department. And also we have some collaboration with all the high schools in Switzerland, international collaboration. I mean, if you consider only the quantum matter physics department, they have something like 250 collaboration all over the world. So I can't go deep in all of them, but as I said, this is quite an international place, so our collaborations are worldwide. And if you are coming for a master here, then you can work in a group which is collaborating with anyone in the world. So that's quite interesting. So what are our specialties? So I will start with applied physics. There are like 5 professors in the group of applied physics. What they do is quite a wide range of specialization. They work on quantum information communication, quantum cryptography. They do biophotonics. They deal with nonlinearity, nonlinear physics, climate change. This is really a wide range. If I should make the whole list, then there will be like 3 pages. That's quite impressive what they do and how different, how many different things they are doing. It is a very active group, and the 2 startups that I talked about before are coming from this applied physics group. The second one is the quantum matter physics. It's the biggest group in the biggest department in the physics department. There is a lot of professors here. They work in many topics from superconductivity, quantum material, ferroelectricity, quantum electronics. They really do a lot of things also, and they are very active. It's the biggest department. The department which is touching to everything is the theoretical physics. It goes from the cosmology to particle physics, so the biggest scale in the universe to the smallest scale in the universe, with astroparticles, dark energy, gravitational waves, string theories, quantum physics, quantum material, biomathematics. And they also work a lot with all the experimentalists that we have, and also they work in international collaboration. We have some theorists working in, for example, in LISA, which is a gravitational waves detector, which should be in space sometimes in the next few years. They are involved in the SKA telescope array in the Pacific. So they're really active in a lot of collaboration with experimental physicists also. And the last specialty is particle physics, corpuscular nuclear physics, which is also really active. Of course, really active in their collaboration with CERN, more especially with the Atlas detector at LHC at CERN. They are also working quite a lot in super and hyper Kamiokande. They do neutrino physics in Japan. And then there are also some activities which is growing quite a lot about astroparticle physics with the CTA in the Canary Island and Chile. IceCube, you can see the Professor Teresa Montarulli in the South Pole, where the experiment is based. And you can see also a picture of AMS, which is on the International Space Station. They all do astroparticle physics. And really recently also, there is a group who are starting some activities in medical physics. The next slide is more like, I didn't know where to put that because at some points I have to say something about that, but they are more from the astronomy department, but they had the Nobel Prize in physics, so I had to say a few words about it. So it's Michel Mayor and Didier Queloz who received the Nobel Prize 2 years ago for the discovery of the first exoplanet. So let's go a bit deeper in detail in the master itself. So the master itself is 2 years long. It's 4 semesters. It's 60 credits for the courses during the first year, 60 credits for the master thesis in the second year. The language of instruction is English. So all the courses are given in English. In terms of registration, you have to register to University of Geneva before the 30th of April 2022. And if you need a visa, it's the 28th of February because it takes a little bit of time to get the visa. So if you need more information, you can just have a look at the webpage enrollment university webpage. The admission condition is quite easy. You need to have a bachelor in physics or an equivalent degree obtained in the university that has signed the Bologna Agreement. If not, then you need to have the authorization by the Physics Section Equivalency Committee. So you have to ask for the equivalence, and they just say if your bachelor is okay or not, or compatible or not with our masters. Often it's just like a few weeks, but okay. So what's the study program? As I said, there are courses. As I said, there is the thesis to do. We have the 5 orientation that I already mentioned. And of course, there is no French. Some people are asking if there are some French exam to pass before coming. Before the master, we don't need French because all the lectures are given in English. So what are the courses? I will just show you the list of the mandatory courses for each master, sorry. I will not go deep in details. You can find all this information on the web page. What I have to say first is the thing that I would like to point out is how the labs are important. The labs is half of the year, so it's 30 credits. There is, if you do the master in elementary particles and nuclear physics, it's like, okay, you do advanced particle physics, normal. You do quantum field theories, normal. This is something that you find in all the master in this field. And then, but the amount of laboratory is quite big. And these are the mandatory course. And also there are a list of optional course, which is really, really long that I can't go through here. Like it's like 100 optional course that you can take. But the place of the lab in the master is really, really big. And it's the same for all of them. For the quantum area physics, okay, you have phase transition, quantum light and matter, you have strong correlation, and you have also lab from the theoretical point of view and experimental point of view. The same for theoretical physics. Theoretical physics as something a bit special, since there is a lot of specialties in theoretical physics. You have the list of mandatory course that all the students have to follow, and then you have to choose at least one course from a list of four lectures, which kind of orientate a little bit your master. If you take a stochastic method, and it will lead you to a given orientation, cosmology to another one. But still the mandatory courses are the same for all the students. And it's the same with the applied physics. There are mandatory courses. Also, the labs are very important. And then you have to choose one of the course from the list in these 5 lectures. And the last one, which is cosmology and astrophysics particles, they have common lectures with elementary particles and nuclear physics, like the advanced particle physics. The labs are the same, I would say. But then you have some other lectures like general relativity, particles from universe, which is really different. So some of the lectures are the same than the one from elementary particles, some others are different. Okay. So here are the important contacts. So I can leave this slide a few minutes if you want, just to let you write the emails, the interacting emails, or you can find them on the web page anyway. If you have any really detailed questions, like if I choose this master with this lecture, can I do that? The good person to ask for is the academic advisor for the physics section, which is the Professor Patricia Parouche. And you can write an email here, and usually she answers quite fast. Or you can ask also the academic advisor at the Faculty of Science, which can give you some general hints for your questions. About professional prospects, you already know that since you're already a physicist. The Master of Physics leads to really a lot of opportunities in Switzerland, of course, but all around the world. You can find a job quite easily after a master or a PhD in physics, and anywhere. It can be research, academic research after a PhD. It can be industry. It can be medical application. It can be teaching. It can be finance, management, climatology, energy, environmental applications. Some of our former students are working now in Météo Suisse. There is even an orchestra conductor who did a PhD in physics and now is doing music all the time. There is no link, but still. Since the physics education in physics is giving you knowledge, methods that you can apply wherever you want, that's quite easy for a physicist to find a job, even not in physics, because the method that you learn, you can apply it wherever you want in your life, in your professional life. So this is something really important to remember. It's hard to say. Sometimes when I talk about the bachelor, I see some young students finishing high school saying, okay, what kind of job can I do? I always say, okay, I don't know, because I don't know about the jobs in 10 years. Probably most of the students are going to do a job that doesn't even exist right now. So it's hard to say you can do that job, that job, that job. But the important thing is just to remember that the method that you learn at university, and more especially in studying physics, is giving you like very interesting methods that you can apply wherever you want. And then to end with, just give you some two interesting link that you should have a look. So it's the web page of the physics department, physics section. The first one, where you can find most of the information you need for the master. And the second one is the official web page for the masters at University of Geneva, where you can find some information about the master in physics.